So in the tail part of the last lesson, or the last day of this lesson, we were just getting started and talking about question number 7, where we want to make a scatter plot of the data shown in the table from question 5. And so let's take a real quick look at that. And so if we let's lay out our graph, of course, first. We of course want to make sure that we label our x-axis here. And our y-axis is, of course, up here. And the x-axis, we're talking about the amount of time in weeks. Okay. And over here on the y-axis, we're looking at the amount of money saved in dollars. Right? Okay. So now we want to, of course, label our lines for our grid. And just because of the confines of space, I'm going to skip. My scale for the x-axis is going to be 1. But as you can see, I'm skipping every other line just to make life a little bit easier. Okay. And then on the other side, I'm going to go up by hundreds, but I'm going to skip every other one. So the first one will be 100, then 200, skipping every other just so I don't have a mess to deal with. Okay. I'm certain that you can probably do a much neater job on yours than I am doing here, just because well, it is rather difficult. Okay, so now let's, like it says, they want to make a scatter plot of this data. So remember, in the first week or at 0 weeks, we had, or what's his name? Manuel had $1,050. So halfway between that and that, we put my little dot there. Okay. And then in week 1, he was down to 1,000. And week 2, he's at 950. Week 3, he's at 900. And going down by that every week. That one was a little off, but we're not going to worry. Okay. So we went down as far as 6 weeks on the table, and that put him at 750. And we could keep going, but we only need to make a scatter plot of the data that runs through those points or through those weeks. So I could actually, just to be a stickler, I'm going to get rid of this dot here. Okay, because I don't need it. So now we could take a look at making a line, drawing a line through the points that we've plotted. So go over here, we're going to insert a line that I will start there and connect it through those points as best I can. Doop. All right, there you go. See? And there is our line through the points that we've plotted. Beautiful work, Mr. Eaton. Beautiful work. Okay, well, let's move on then to the next question. Question 8 says, what will happen to the table, the function rule, and the graph if Manuel spends $100 each week instead of $50 each week? Well, obviously, if we replace the $50 per week that's leaving with $100 per week, well, then there would be a new spending rate, right? The graph, of course, would still fall, but the line would be steeper. So on the graph, okay, well, let's try this one more time. For the graph, we would have a steeper line, right? It would still be a negative slope of a line, but it would definitely be steeper at $100. And then because the slope would represent the greater decrease each week. Instead of 50, it would be 100. The values of the table would decrease at a faster rate because he's spending the money at a faster rate. So for the table, the values would decrease faster. Why doesn't it? There we go. Decrease faster. All right, because he's spending that money. And then how would that affect our function rule? Well, obviously our function rule would be different because instead of having the minus 50, it would be minus 100. So then the y, which is the amount of money in his account, would be equal to that same 1,050, but it would be subtracting it at $100 per week. Okay. Now let's take a look at question number 9. Consider this diagram. Then explain how you know that the slope of the line is the same between any 2 points on the line. So what they're asking us is, how do we know that the slope of the line from here to here is the same as the slope from here to here? Well, that seems pretty straightforward, right? I mean, you could pick any 2 points on any line. And then if you were to connect those points as they did here with, a right triangle, soup, right? Right triangle. Well, those hypotenuse of those right triangles, they lie on the exact same line, right? And so the corresponding angles of these two triangles are congruent because they would have to be. The triangles are similar because of the whole angle similarity, right? Got this angle here, and this angle here, and this angle here. They are the same, right? So again, this angle and this angle are exactly the same. This angle and this angle are exactly the same. And so because of that, they would have to be similar triangles. That means that the hypotenuse is the same. And so they're going to have the same slope. So the ratios of the corresponding pairs of legs of the right triangles are equal. And so those ratios, remember, would determine the slope of this line. Remember, the rise over the run, the rise over the run. It's all going to be the same just because I could even pick, I could take and say, the distance from this point to this point, and that would create an even larger right triangle, but it would still have all the same characteristics. And so the hypotenuse of that line, the slope of that line will always be the same. No worries. Okay, so now that brings us to question number 10, where we need to determine the rate of change for the given data. Now remember, the rate of change is the same thing as the slope of a line. And remember, we always represent the slope of the line, as m, but that's neither here nor there at this point. So in order to determine the rate of change, remember, we are looking for the change in y over the change in x. And remember, the change in y means the difference. And you find the difference by subtracting. So make sure that you are finding the difference in y over the difference in x to find your rate of change or the slope of the line. And you could draw it out on the graph too. Now, question number 11, I don't want it to throw you off. It's a graphing calculator diagram. Describe the 3 different ways you could calculate the rate of change for the data shown on this graph. Well, you could enter the amounts in a table, right? You could always make a table of the values of X and Y, right? You could make a table. Another way is you could use the graph. You could draw the vertical and horizontal changes between the data points. So you could go, well, let's see. It goes up and over, up and over, up and over, up and over. So you can always find the rate of change that way. Rate of change, slope, change in Y over the change in X, rise over run. And then at any 2 data points, you could just, like I said, these stair step things, you go up, 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 up. But like we discussed in question number 9, I could even pick this point here and this point here and determine what the change in Y over the change in X would be between those 2 points. And I would label those 2 XY pairs and find the difference between the Y's over the difference of the X's. No problem. Not a problem at all. All right. Well, I'm going to let you finish the rest of this thing up on your own. Question number 12, Griffin working at a local burger stand. He works 10 hours a week. He makes $80. He works 15 hours a week. He makes $120. If you graph the line that contains these 2 points, what will be the value of the slope? Right? And what does the slope represent in this situation? The rate of change, slope, change in Y, change in X. All right. And then there's more with question 13, more stuff about Griffin helping his brother study for multiplication for 10 minutes. Anyway, so I'm going to let you finish the rest of this on your own. I'm sure you're going to do a fantastic job. Have a great rest of your day. Don't forget to be awesome, and I will see you next time.